Assalamualaikum warahmatullahi wabarakatuh. Today, our group will be presenting our group assignment MEM560 manufacturing process. So, for our group members comprised of one Daniel Shafiq bin Wan Abdul Rahman, one Muhammad Akif bin Jafri, Zafranuddin bin Kamaluddin, one Ahmad Shahmi bin Wan Amir Zaki, and finally me, Ashraf bin Zainal Abidin. So, for the company we chose is Ken Wan Berhad. So, what is Ken Wan Berhad? So, to introduce the company, Ken Wan is an investment holding company. Its subsidiary companies are principally involved in the manufacture of several products such as metal and lithograph cans, plastic jerry cans, bag-in-box. Said subsidiary companies also involved in the manufacture, packaging, and distribution of dairy and non-dairy products. The company also owns Aikju Can Factory Sendirian Berhad, which has been involved in the manufacturing of tin cans for more than 40 years. It started from a small tin can manufacturer, but is now one of the leading tin can manufacturers in Malaysia. So the background of the company. Ken Wan was founded on 7 January 2004. Ken Wan Berhad was listed on the main board of Bursa Malaysia Securities Berhad on 29 July 2005. Ken Wan Group's venture into the manufacture of plastic jerry cans via Aikju and Kanzo Sendirian Berhad, another wholly owned subsidiary company. So the company started with 2 jerrycan lines in 2003. It has since expanded to 50 jerrycan lines as at current date. In order to meet customers' demands for substitute packaging products, the group introduced bag-in-box in 2008, thereby widening its range of packaging products. So that is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Shafiq bin Abdul Rahman. Today I would like to present about manufacturing process and technology. The two-piece slim breathable aluminum can is an advanced aluminum can made from breathable technology. This technology is used by major non-carbonated soft drink filler to set up their retort and pasteurization process system. The following are the two primary advantages of the aluminum-free engineering process. First, enable rapid identification and removal of leaky cans before and after retort, using post-incubation time. Second, allow for improved heat conductivity. This improves the retort heat efficiency. Making a two-piece slim breathable aluminum can consist of the following steps. First, deep drawing and blanking. Modern aluminum beverage cans use two-piece drawing and wall ironing. The process begins with an aluminum ingot which is then rolled into a thin sheet. The container bottom and side are made by cutting a blank from the sheet. The blank are 13 cm. A small quantity of aluminum is wasted when the sheets are large enough to include two staggered row of 7 blanks each. However, some of the sheet can be recycled as scrap. After cutting the circular blank into a 8 cm cup, it is pulled up. Second, and forming and wall ironing. The first machine cup will be moved to the second. The sleeve hold the cup in position while the rapid descending punch redraw it to a 6 cm diameter. With the help of 3 ironing rings, the punch stretch and thin the cup walls. This step takes only a quarter of a second. This method iron and thins the can body by sandwiching it between punching slivers. Spraying coolant and on equipment and materials require coolant rinsing and wastewater treatment. It's currently 13.3 cm tall. The second punch causes the cup base to extend inward. This type counter the carbonate liquid pressure. This reinforces the can's bottom and wall. Third, trimming. An axial push raises the vacuum plate to the necessary trimming height in the trimming machine, so the movable cutting unit can be directed. The ring between the upper and lower cutter is burr-free slash. The cut rings are vacuumed out, bundled and returned to the tin plate mill. Pot cleaning and decorating. Drawing and ironing leave the cans outside smooth and lustrous, reducing the need to polish. The can is then washed and imprinted with the name. In order to form the can's name, The top flange is folded over after squeezing it slightly. 5. Necker flanger. Necker reduces the top can's diameter. The thicker top of the can with the full top costs extra. The flanger uses the flange to attach the flip or end. A reformer straightens a light dome by grooving it deeply. This stage is used for beverage cans before pasteurization. The profile technique saves material and allows the can to be stored on a shelf or in the fridge. This straightens the can. 6. The lid. Unlike the base and size of the container, the lid is made of an aluminum alloy. In contrast, the flat lid is constructed of aluminum with more magnesium and less manganese than the base. The result is a thicker lid and stronger metal. A tool pushes the lid center outward to form a rivet. The pull tab is inserted and fastened with a simple pull of the lid tab. The metal separates and the required spacing is left. Inspect for crack and pinhole immediately. 7. Quality inspection. The examination should be based on the agreed upon AQL acceptance quality level. They offer comprehensive quality assurance service. At each level of the production line, a KJCF quality representative inspect the product. Here is the process inspection flow. First, check the quality team corrective action. Second, at several production stations, inspect and identify low quality links. Third, pre-assembly examination of product and components. Fourth, identify the supplier's production system problem. Lastly, filling and sealing. The net is shaped here. A filling machine pushes the liquid into the can. The lid was shut. The top flange of the can is curved and sealed, and the can can be sealed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ahmad Syambi bin Amir Zaki. My student ID is 2020859756. And today I would like to present about design concept and quality assurance. So each year, about 500 billion aluminium beverage cans are manufactured and distributed internationally, and almost all of them share a common fundamental design. It is divided into three shapes, which is first spherical, second cuboid, and the third one is cylinder. And the cylinder is the most often used can shapes. So what are the company goals on the design concept? First, to reducing the material waste. Given the volume of can produced each year, each bit of optimization has significant economic and material benefit. Making portion of cans a few millimeters thinner can result in hundreds of thousands of pounds of metal being saved annually. Second, meet the consumer expectation. Ascertain that our packaging options meet the expectation of consumers for a truly exceptional product, namely freshness and simplicity and health. So for the first shape is spherical shape. The advantage is spherical shapes make structural sense since they use less material per unit volume and are subject to uniform stress. It is because you have no weak edges or corners. And the disadvantage, however, it will roll off the tables and will be inefficient to package and distribute. So for the cuboid shape, the advantage is a cuboid shape could be placed on a table easily and pack up. The disadvantage, when we hold to drink, on the other hand, it will look awkward. Additionally, it edges highlight vulnerable places that require additional fortification. So lastly, the most popular shape is a cylinder, and the advantage, the cylinder resembles a sphere from the top, while from the side it resembles a cuboid. Among other things, it can sit on a table much like a flat side cuboid and rest pleasantly in your palm. Cylinders are substantially more effective in packing and spears, but not as efficient as cuboid. Additionally, they can be made quickly. So, how to make a cylinder can? First, to produce a can, a flat metal blank is forced through a die, resulting in the formation of cup. The technique is continued until the desired height, form and thickness are achieved. Then, using the doming tool, create a rounded impression on the rim due to the shape strength. This art requires less material than a flat bottom. It disperses loads horizontally as well as vertically. So the picture on the right side is how it was made. And the next one is the neck is formed by a drawing the top of the rounded cup shape can inward. The machine the can cover, securing it with an ingenious and sturdy double seam to the body. By exerting force on the exterior, the seal internal pressure can assist in strengthening its thin size. The side behaves similarly to a chain. They are strong in tension and weak in compression. Soda cans, unlike unpressurized food cans, do not require corrugation to maintain internal pressure. So this is the neck, how we form the neck of a can. And lastly, for the tap can, for drinking, venting, the original flat top can had no tap and two apertures. Pull tab were a good start. Despite this, they littered the street and were frequently ingested by children. So to create it, this variation is a clever engineering feat. The rivet is a lever. Once depressed, when we open the tap, allowing you to dive into your dream. Just open and drink your drinks. So for the discussion on the design concept and quality assurance, their cutting-edge technology has improved the quality of their goods and services. This mix of human and technical resources make them one of Malaysia's most established firms. Second, they believe that regulating and running processes that affect performance can make significant impacts. Continual human growth and solid financial support will help us accomplish their quality goals. Their registration ISO 9001/208 requires regular preview and evaluation at all levels. And lastly, the majority of Can 1 Berhad, the company name, the subsidiary that supplies food chain sectors adhere to good manufacturing practices (GMP) and HACCP certification has been granted to all of their products. So I think that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akib bin Jeffrey. Today I would like to present my part. For the first one is the product produced. First is two-piece slim rotatable aluminium cans. The first one is 200 or 211 can with item capacity 300 ml. The next one is slim 200 can with item capacity 250 ml. And the stubby 200 can with also 250 ml item capacity. And the last one is for standard 200 can with item capacity 350 ml. Next, we move to the two-piece DWI steel can with item capacity 500 gram. And the third one is three-piece beverage can. The first is beverage round can with 250 ml. And the next one is beverage round can with 325 ml for the item capacity. And the last one is stubby can with item capacity 150 ml. That's all for the product produced. Then we move to the problem phase. The first one is laminate plate. This is known as a defect where the metal body or end plate is separate into two layers of metal which are not bonded. It also can define as the thin and flat surface separation present inside the metal plate. It usually occur during rolling process. Lamination formation is mainly caused by presence of discontinuity present in the metal, such as porosity trapped in the slab. Okay, the defect can occur within the body of the plate as
The cause of the defect also will affect the strength in thickness direction. The next one for the problem face is the wrinkles. It's actually occur at the can beverage at the early stage during deep drawing operation. It also known as defect in wrinkling of sheet metal material, usually in wall or flange of the part. During stamping process, the radial drawing stress and computer stress will be applied to the flange of the blank and resulting the wrinkles. One of the cause that affecting wrinkle defect occur there is the die temperature and metal alloy during the drawing process. The next one, we move to the cold solder. Cold solder actually is a rough and spongy irregularity of the side seam solder fillet or a discontinuity with a gap or voids that occur at the pathway through the side seam. Cold solder defect also mostly is occurred at the extremities of the side seam, and also the most common cause of cold solder defect is because the cell temperature is too cool. For the fault is the distort reform risk. This defect actually is known or can be identified by the creasing body and flange area on the reform ridge of reform cans. It can cause plate fractures and compromise the double seam's integrity. For the common cause of this defect is caused by the improper flattening of a can body cylinder. We move to the last one for the problem face is false seam. False seam actually the defect mostly caused by the absence of overlap. Next, the defect can be recognized by a portion of the body is bent back against the body. The body flange is evident below the end hook radius. We can be easily explain just like a knockdown flange flow. And the last one can describe this false seam is it can be identified by close visual inspection of the underside of the double seam. That's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Zafranuddin bin Kamaluddin. Now I'm going to present about discussion and also comment and recommendation about our distort research of our chosen company, which is Ken Wan Berhad. We begin with discussion. Nowadays, many manufacturers utilize and rely on technology to keep their products free from any flaws or any rejects. This is because this might jeopardize the quality of the product and it will cost them some money in order to rectify the situation. This product manufactured by Ken Wan Berhad, it is specialized in mechanical engineering. Therefore, they employ mechanical engineering specialists in order to assist them in the production of the product. Majority materials utilized are of excellent quality such as aluminium and also reusable such as plastic covers. Every day, workers in this company are dealing with machine. Therefore, safety values are extremely emphasized at every step and inch in this company. In order to protect the worker and reduce a risk, safety precautions such as wearing a jacket, glove, safety shoes, goggles and earplugs are required. If you can see at a picture, in this slide, a worker are wearing glove and also earplug when he is dealing with a machine to avoid an injury from happen. Next, safety signs such as caution, danger, and others are placed in strategic location to give them reminder to always alert with what they were doing. Besides that, fire extinguisher also placed in strategic area. Therefore, the workers can use them quickly and also efficiently when a bad thing happen. On top of that, company also provide a safe haven and a location for gathering if fire case or other emergency happen. Safety is very crucial for all the workers and also the company itself. When safe and comfortable environment is exists, the workers will feel ease to work and the processes will be done efficiently. Several issues and defects are uncommon in the production of this product, but unfortunately it happened. Laminated plate, fault solder, and also fast seam are examples of the defect that the company face in the production of the product. Therefore, this company, K1 Berhad, should take a step ahead and improve technology in order to minimize the defect that happen in their product. The best way to keep satisfied and the customer happy is to always maintain the quality of the product and also improve in the future. Alright, we're moving on to comment and recommendation. This desktop research adds and helps us for better understanding on how the product was made. But in our opinion, a few tasks such as a description of the machinery handling method, safety precaution throughout the manufacturing process, and industrial waste management or treatment procedure should be included into the assignment for improvement. It will assist the student on learning new technologies and also becoming familiar to them, as some of them might be not be covered in the lecture class. Next, knowledge on how to operate manufacturing machine is very necessary, since some of the students wish to pursue future profession in this manufacturing industry. Besides that, students should be instructed and guided on how to use tools and material with good technique. Awareness on the safety issues are very critical, especially when they are dealing with sharp tools or hazardous chemical during the manufacturing process. Students should learn how to properly handle and dispose of industrial waste to prevent harm to the industry and the environment. In our opinion, students will have difficulties in explaining the detail of the product manufacturing process, since they had not the opportunity to work in the real world setting and observe the first hand. Students don't have a chance to demonstrate and apply the manufacturing idea that they have learned in the class. Therefore, real site visit is preferable than desktop research, so that the student can learn more effectively and can improve their knowledge retention. This is some of the references that we been used in our desktop research.